Historically, the .NET Framework has provided several different techniques for working with XML. You had your XML document, your XML reader, your XML writer, and so on. Visual Studio in the .NET Framework provides techniques, and they're actually useful, good techniques. You'll find a set of classes in the system.xml.link namespace that make working with XML a lot easier than any other way you've got in the .NET Framework. LINQ uses these classes and provides a standard, language-based mechanism for querying, transforming, and working with XML content in general. But they're linked together. The classes in the system.xml.link namespace are required for LINQ to be able to do its work. Now, I will mention there are some differences between Visual Basic and C# support for LINQ to XML. Both languages fully support the system.link.xml namespace and LINQ working with XML, but Visual Basic adds several features that simplify working with XML in general, and specifically working with LINQ to XML. You'll find XML literals, that is, the ability to just place XML code in your code stream as a block of data. Like a date or an integer, XML is a built-in data type in Visual Basic. XML replacements allow you to easily create XML content with replacement tokens that get replaced at runtime. It makes it easier to provide programmatic interaction with XML. VB provides XML access properties. Using a standard syntax, it becomes easy to navigate through XML content, finding ancestors or children or siblings of various nodes in your XML content. With C# you can still do this, you just have to call methods to do the work. VB supports another feature which I didn't mention here, which is if you have a schema, an XML schema associated with your project, then you get IntelliSense as you type XML data that uses that schema. There are a number of other Visual Basic only features, which for C# developers you might find it interesting to go investigate. For Visual Basic developers, we'll cover them in this course. Let's get started by creating XML content. Often, you'll need to generate or modify XML content in code. We'll start by reviewing the old techniques, and we'll compare to the techniques that are added to your toolbox because of the addition of LINQ to XML in the .NET Framework 3.5. We'll have demos investigating using XDocument, XElement, and similar classes. We'll use XPath expressions to find specific nodes, and XML features to modify XML content. Now, we're going to be creating XML using the XML document to start with. This is the old way of doing things, just to get your level set so you know where we're coming from. Most developers have used the XML document class to create new XML content at this point, and it works fine. The problem is it's somewhat opaque. That is, your code, the code that you write to create the XML content, is difficult to read later. You can't just look at the code and see what your XML content is going to look like once you're done. Imagine that you need to create this simple block of XML. Using the XML document class, it requires a little bit of code. This is the XML we're going to create. Just a simple declaration, comment, and root element. Each node you create requires a few steps. You'll need to call a method of the root node, and that's actually the document itself, to create the new node. And then for each node, you'll need to append it as a child of an existing node within the document. Well, let's run an example just to look at the old way of doing things so we have a basis on which to compare the new way of doing things. I'll choose option A in our sample project to create the XML document using some of the old techniques. Here we are. And we'll start by creating a new XML document. That's how you had to do this using the XML document class. Next, we'll create our declaration. We'll call the createXMLDeclaration method of the document, passing in parameters indicating how we want that declaration to look. And we'll append that declaration as a child of the document itself. Then we'll create the comment. We'll call the createComment method of our document, passing in the information we want in that comment, and append it as a child of the custom document. Then we'll call createElement of the custom document, and we'll pass in the information we want, which is the name of the element, and append it as a child of the document. Finally, we'll save the document and then display the results in our output window. Just as in other projects in this course, the display results method has several overloaded versions, so we can easily display content into the console window for this demonstration. If I press F5, you'll see that we did manage to create the required XML using the old techniques. In each case, we had to create the node, then append it as a child of some other node somewhere. And only the document itself can create new child nodes, though you can append them as a child of any existing node. Well, that's the hard way to do it. If you look at the code again, you'll see that given this code, you would be hard-pressed without actually reading it carefully and trying to compile it in your head. You wouldn't be able to tell what the output would look like by just reading this code. Hopefully, we'll find a better solution in future examples. As you've seen, the XML document class makes it possible to create new content, but it doesn't make it easy. Each node requires at least 2 lines of code, at least 2 logical lines. You have to create the new element and then append it as a child of some parent node. As I mentioned, the .NET Framework adds a set of classes in the system.link.xml namespace like xDocument, xElement, xAttribute, xComment, and so on that makes all of this a lot easier. These classes provide constructors that accept arrays of objects, that is, multiple objects that allow you to create the object, the new XML element, and so on, declaratively in your code. The demo introduces these classes, and these are the basis for LINQ to XML, because LINQ to XML works with xElement, xAttribute, xDocument, and so on, because you'll be working with collections of these elements and querying these collections of elements. So let's run a demonstration that shows how you can create first a simple block of XML and then a more complex block. I'll choose option B to create some simple XML content. Here, we'll start by creating a new xDocument. You can see that because although I've used the var keyword, on the right-hand side of the equal sign, we have new xDocument. This xDocument contains within it some XML content, a declaration, a comment, and an xElement. It really couldn't get much easier than that. Here we've declared the objects and provided values for them. In addition, you can see that the constructor for xDocument allows you to pass a virtually unlimited list of other objects, and those become the content of that xDocument. Here, if I step through this, I've created now the customer's xDocument, and if I visualize it, this is a little tricky. Let me go over here. Visualize, I click that arrow, choose the XML visualizer, and now we see the XML content that we just created. The declaration doesn't show up here, but it is in the file. If I press F5 to display the output of the file, you see it contains the declaration, the comment, and the root element. We can try option C to create a more complex block of XML. Here we're creating some nested elements. We have in this one line of code, and this is all just one line of code neatly formatted, we create an xDocument object, and the xDocument is passed in its constructor, looks like 3 elements, well, 3 nodes, a declaration, a comment, and an element. Within this element, the name is customers, and the content starts here and goes to here. So that's the content of that customer's node. Within that customer's element, we have a customer element, and here's the content of that customer element. We have an attribute, customer ID equals micro. We have another element, a child element, name is company, value is Microsoft. Another element, name is contact name, value is Andrew Fuller. Another element, name is country, value is USA. Another element, name is orders, and here is the content of that element. It's an element named order with an attribute of order ID equals and the value of the order ID. So even though we're creating some rather complex nested XML content, it's certainly easier this way to determine what the XML looks like by looking at the code that creates it. In addition, C# does a pretty good job as you type this content of formatting it for you. It indents correctly so you see the levels of containment within the XML content. So it's pretty easy to type this XML as you enter it into the code editor. If I run this full speed, you'll see we just created this XML content using this code. Pretty easy to read this and see what the resulting XML will look like. It's not nearly as opaque as the older technique was. When you want to search through XML, you generally use XPath. That's a grammar of XML that's dedicated to searching. And the .NET Framework has historically supported XPath in the system.xml.xpath namespace. LINQ does supply bridge procedures allowing you to access the existing functionality. So imagine you've got some X element or X document object and you want to search through it using XPath. Well, since you're using a LINQ object, you need to use some LINQ feature to use XPath to search it. You can use the XPath select elements and XPath select element methods to search through that data. These allow you to supply an XPath expression, and the methods return an IEnumerable of XElement collection, or a single XElement instance. Of course, once you have that enumerable of XElement collection, you could use LINQ on it, and we'll talk about that a little later on. Now, I can only say this a certain number of times, but you're going to have to believe me. These methods are special. They're extension methods which are built, they live, in the system.xml.xpath namespace. They extend the XElement, XDocument, and XNode classes, which are in a different namespace altogether. You have to import the system.xml.xpath namespace in order to be able to use these methods. You'll try typing XElement.xpath select elements and you'll get no IntelliSense, and the code won't compile unless you import the system.xml.xpath namespace. It's the only place I've seen where you absolutely have to import a namespace in order to be able to use a method. Let's try an example which shows off traversing XML using these methods. I'll choose option D to traverse XML here, and here we'll load up an existing XML document. Let's look and see what that XML document contains. I'll choose the XML visualizer, and there it is. Let's make it wider so we can see it, and taller so we can see some stuff. And you'll see here the root element is named customers, and within that root element we have various customer elements. Some of those customers have information about orders in them. For example, this customer includes an orders child element. Within the orders child element, we have order elements, and each order has information about a particular order. Only a few customers have this information included in this XML content. What I'd like to do is look through all these customer elements and find the ones whose country element contains USA. How do I do that? Well, here I'm going to call the XPath select elements method of that customer's XElement node and look for this XPath expression to match any child element. This indicates that I want to look at any level beneath the current node. That's what the 2 slashes indicates. I want to find a customer element. Within that customer element, I'm looking for a child element named country whose value is USA. This is a very simple XPath expression. They obviously get much more complicated, and there are other ways to do this besides XPath. But for now, I'm using the XPath select elements method given this XPath expression. At this point, I have a collection of XElement objects, and I'd like to display them in the output window. So I'll step into this procedure so you can see once how it works. For each item in the collection, we're going to display, by calling display formatted results, the item's attribute and child element information. Now, these attribute and element methods are called access methods, and they allow us to retrieve information about a given element. Attribute obviously gives us attribute information, element gives us child element information, and here we want an attribute named customer ID, and we want its value. We want the value of a child element named company and the value of a child element named phone. If I press F5 and let it go, you'll see I get here all the information I requested. We'll be looking at other ways to solve these problems in later examples. You may have noticed in the previous example I did a bad thing. I looked for an element, a child element, using the element method, given the name of the element, and then just retrieved the value property. Unfortunately, the element might have been nothing. It might not have existed. So you can't really call the value property of an element you're searching for until you confirm that the element actually exists. That code could have blown up, but I knew those things existed, so I'm not worried about it for this demonstration. But back to our topic. Most developers view XML content as a tree-based structure in memory, because that's what it is. Every node, except the root node, can have a single parent. Every node can have multiple siblings, children, grandchildren, and so on, but only one parent node. Starting on any node, you can move up to a parent, except for that root node, down to any child or grandchild, or horizontally to a sibling, and you can also retrieve an attribute, which is much the same as retrieving information about the node itself. Each direction that I just mentioned is called an axis. The system.xml.link namespace provides methods you can use to traverse these axes. Here's a subset of what you have. You can use ancestors to go up to any ancestor, or ancestors and self. Ancestors and self would retrieve a collection of all of your ancestors and yourself, the node you start on. There's an attribute method which retrieves a named attribute, and the attributes method which retrieves all attributes of a node. There's the descendants method, which hands you a collection of all the descendants, and you can index into that collection using a string, which indicates the name of the one you care about. There's the element, elements, elements after self, and elements before self, which looks either at the element itself, that is a child of the current element. There's elements, that is all the children of the current element, only one level deeper. There's elements after self, looks at siblings to the right of the current node, and elements before self, which looks at siblings to the left of the current node. And there's the parent method, which returns the parent node of the current element. Our display company's procedure we just looked at used some of these, including the attribute and element access methods. You can use methods in the system.xml.link namespace to update XML content. If you want to add a child element, call xelement.add. If you want to remove an element, call xelement.remove. If you want to set a child element's value, call xelement.setElementValue. To do that, you'll modify an existing child element value, or create a new child element, or delete a child element. That setElementValue is very powerful. That is, if you call setElementValue and supply the name of a child element that already exists and a value, you'll modify its value. If you call setElementValue and pass in the name of a child element that doesn't exist yet and a value, it will create it and set its value. If you call setElementValue with the name of a child element that does exist and supply nothing for its value, it will delete the child element. Pretty smart method. Let's try an example that shows off updating XML content using these methods. To demonstrate updating XML, I'll choose option E. Here we are in the code, and the first thing we'll do is load our large XML document. Right now, I'd like to find an existing customer, so I'll use the XPathSelectElement method, given an XPath expression that returns the one I want, which is the customer whose customer ID attribute equals GREAL. Now, of course, if that customer didn't exist, we have a null value in customer, but in this case, we do actually have something, and we'll display that customer here in the console window. We've retrieved that customer, and now we'll do work on that customer's XML content. All right, now here we're going to create a new element, a new X element, with the name mobile and the value listed here. Once we create that X element, it's easy to add it as a child of that customer by calling the add method. If we look at customer now, you'll see there is a mobile element that wasn't there a moment ago. It's easy to remove an element. We say customer.elements named orders and remove that. If there was more than one element named orders, it would remove them all. We'll remove the one orders element, and you can see it right there. It's going away. Gone. Now we'll call the setElementValue procedure 3 different ways. First of all, we'll modify the value of an existing child element. Fax is already there. We're going to change the fax value to be 5550123. Here we'll create a new node. Home doesn't exist, so because we're calling the setElementValue method with home as the name of the element, it doesn't exist yet, it will create it and set its value. Here we're going to remove a node. This is an easy way to do it. Just by setting the value of an existing node to be null causes the code to remove the node altogether. Phone is gone. Wanted to show one more thing, which is an easy way to set the value of an element. We don't have to call the setElementValue method. We can just set the value property ourselves. On the other hand, if that element didn't already exist, this would cause a runtime exception. The setElementValue would create the node for you. But in this case, fax does exist as a child of our customer element, and so we'll change its value by setting the value property. That's it. We display our modified customer, and you can see we've added home, we've added mobile, we've removed orders, we've changed the fax value, and so on. So we've done a lot of work on this customer's XML. If we were to save the XML file back to disk, we would save this customer's changes. You might want to verify XML content against a schema, and the system.xml.schema namespace provides an extension method for the XElement class, and it's named validate. This allows you to validate the contents of an XElement against a schema to make sure it matches the schema. Now, in order to use this, you're going to have to import the system.xml.schema namespace in order to use the method, just like we did with system.xml.xpath before. The validate method allows you to specify a schema collection instance containing one or more schemas against which you'll validate. Now, it's going to raise an exception if it fails, and we can trap that exception. You can also supply the address of a procedure to call if the validation fails. And this must be a validation event handler delegate instance. Our demonstration won't show this off, but the documentation does. If you want to have your validate method call a separate procedure if validation fails, you can supply a validation event handler instance and pass the address of it to the validate method. In our case, we're just going to raise an exception and see what happens. Let's try success and failure while validating a schema. If you look at our project, you'll see that it includes a customers.xsd schema file here. If I open this up, it represents a schema for our customers.xml file. Where did this come from? Well, it's kind of tricky creating schemas, but Visual Studio makes it easier. If I look at this XML file loaded up in Visual Studio, on the XML menu, I can choose Create Schema. Now, this won't work well for every single block of XML, but since this XML is very regular, that is, every customer has the same information inside of it in the same order, the Visual Studio tool can do a pretty good job generating a schema for you. And here's the schema I've already generated and saved in this file. And that's the schema we'll be using to validate XML. All right, so how do we do it? Let me run this and choose Validate XML1. That's letter G here. Go to full screen. And now we start by loading up our XML content into the variable named customers. You'll remember that contains all of the XML you just saw. There you go. I need to create an XML schema set, and that is going to have all of the schemas against which I want to validate in it. Here we add our schema to that collection. Now we're going to use a try-catch block because later on this validation is going to fail. Not yet though. I know now that since I generated this schema based on this XML file, it's going to work fine. I call the customers.validate method, passing in our schema set and display the results, and clearly it was successful. Everybody's happy. But let's try it now where I modify the XML so it isn't valid anymore. We'll come in here, and this time we'll follow the same exact steps, except before I do anything else, I'm going to remove the customer ID attribute. Here's how it works. I'm going to say, let me find the customer whose customer ID is ALF_key, and then find its attribute named customer ID and remove it. Gone. So although we have well-formed XML still, there's no rule in XML that you have to have an attribute. It is no longer valid because the schema indicates, when it inferred the schema, that we had to have that attribute there because every customer element did have it. So now, since that's required, we're going to attempt to validate our schema. It will fail, we'll catch the exception, and we can display the message. We get an XML schema validation exception. We'll catch it, display the results, and you'll see that we failed because the required attribute customer ID is missing. It didn't tell us where it's missing, but at least it told us that on some element that customer ID was missing. So we've shown here how to both validate successfully and what happens when the validation fails and how you can deal with it in your own code.